Hello everyone, welcome back to our channel. Today we are talking about a new project requirement that just landed on our desk. We would like to share it with you and discuss the problem statement and requirement we need to tackle. This project is all about soil image classification using convolutional neural network. We will be delving into the world of machine learning to analyze soil images and categorize them into different types. So let's explore the details of the project together and brainstorm some strategies to tackle this exciting challenge. We are looking forward to sparking some innovative ideas and exploring the possibilities. Let's just start with the discussion. So this is the document that consists of the project requirement and instructions, and we will be going through this in more detail. Now, so as we already know that the title of the project is Soil Image Classification using Convolutional Neural Network. The project aligns perfectly with the learning outcomes we aim to achieve. We delve into real-world tasks that by utilizing machine learning methods, specifically focusing on supervised learning techniques for descriptive data mining tasks. Primary objective of this project is to develop machine learning models, particularly convolutional neural networks, for soil image classification. Through this process, we will not only train the model but accurately categorize soil images into different types but also fine-tune its hyperparameter to optimize performance. Additionally, we will synthesize our methodology and finding in a clear and concise manner, ensuring effective communication with diverse audience. Now let's dissect the requirement laid out in the document. Soil image classification is essential for various agriculture and environmental applications, necessitating accurately categorizing of soil images based on visual characteristics. This project presents a unique challenge, training a convolutional neural network to effectively classify soil images into distinct types. Soil characteristics vary widely based on the factors like texture, color, and composition, making it essential to identify patterns and trends within the dataset. Our goal is to train a convolutional neural network that can learn from these visual features and accurately classify soil images. By leveraging the unique characteristics of image soil image, our model aims to provide valuable insights for research, agriculture, and environmental studies. Let's discuss about the assessment task. Our first task is to dive into the dataset and ensure it's ready for analysis. We will explore the dataset, discussing any necessary cleaning or transformation to ensure its quality. Additionally, we will partition the dataset into training and testing set, laying the groundwork for model evaluation. Next, we will embark on building, training, and deploying a neural network for soil image classification. We will propose the use of convolutional neural network for this task, justifying our choice based on their ability to learn spatial hierarchy from image data. The objective is to develop a robust model capable of accurately classifying soil images based on the visual cues. Once our CNN model are trained, we will report and discuss their performance. We will analyze the accuracy and effectiveness of the model in classifying soil images, providing insights into their strengths and limitations. To enhance the performance of CNN model, we will apply techniques such as a dropout, early stopping, and batch normalization. By investing their impact on model performance, we aim to optimize our CNN for soil image classification. Hyperparameter tuning plays a crucial role in optimizing model performance. We will fine-tune the parameter of CNN to achieve the best possible result, ensuring the model are well optimized for the task at hand. Lastly, we will critically discuss the limitation of our proposed model for soil image classification. By understanding these limitations, we can identify areas for improvements and future research direction. Now speaking of the dataset, We have also been provided with the dataset here, which is available on Kaggle. The collection of soil images and classification sourced from Kaggle. This dataset comprises 6 folders, each representing a distinct soil types. Total 144 labeled photos with its diverse range of soil samples. This dataset serves as a valuable resource for studying soil variation and exploring potential relationship with environmental factors. Our task involved through exploration and pre-processing this dataset to ensure its suitability for model training and evaluation. So I hope this discussion, problem statement and requirement may have given you some ideas, or if you are looking for help or guidance from us, feel free to reach out. Drop us a comment below and contact us by email or call or visit our website. We would like to hear from you and help you out. Until next time, stay curious and thank you for watching this video.